the index 7 is 5. So if I run this one, it's going to show me all the numbers. That means the actual values within the index of from 2 to 5. So if I execute this one, it should give me like 3, 5, 6. So also you can access the tuple, the values inside the index. If you need to access the second element, the second element in your list, you can type like your tuple, that means the variable name of your tuple, and then dot index, then the value. So it will give you the value of that. Then also you can like create, when you are creating the tuple, is possible like without the brackets also you can create the tuple like this. It will also create something like this, but you need to know that the basic difference between the list and tuple is that you cannot reassign the values in the tuple. So in the list we can do like your list name, then within the box bracket you can like type the index that you need to replace, the value you need to replace, the index number of the value that you need to replace, and assign the value. But in here, if you try to do it like that, so I create int tuple. So here I need to replace the first value. That means I'm trying to replace this value. That means in the index 0 I have the value number 1. So I am trying to replace the value number 1 in my tuple variable. That means int tuple. So I will type int tuple, then the index and the value that I am going to reassign into that number. So if I try to run this, it will give me an error. So here you can see it's showing me error. If you read the error, it's showing like type error, tuple object does not support item assignment. That means in the tuple, the basic difference between the tuple data type and the list data type is that you cannot change the values. Once you assign the array like this, you cannot change the values inside the tuple type data. So that's the difference between tuple and the list. So the next one is like list comprehension. So list comprehension mean you can like do looping structures inside the list without doing it like this. Just imagine string list. So let me run this one. String list, so I can create this list. Let me create this list. So I will create it like equal. Then for easy purpose, I will copy this one, because I didn't run this command previously, so it will give me an error. For that, I will copy this one and try to create the string list, and I will try to execute this one. So when I try to execute, it's executed. Here you can see now I have a string list. In here, the first index is simple thing, the second one is stuff, and the third one is trunk. So now I will try to print this one. So to print this one, you can type str, then your list name, the variable name. So if you press shift enter, it's going to show you the values in your list. So now if I need to change, that means if I need to do like uppercase or lowercase, just imagine I need to uppercase this simple thing into the caps lock letter. For that thing, I can use something like this. That means here, what does it mean? The string list within box bracket 0 mean is going to access the first value of this index. So the first value of the string list is this one. So if you see here is the number 0, that means simple thing. So here is accessing that value. So and it's asking like equal string list 0. So it's assigning like trying to change the value in that actual value. So here is selecting the string list 0 and then dot upper. Dot upper mean then the value, what's the value inside in here is like simple thing. So in this command is trying to do like uppercase. So if I execute this command and print the list right now, so you can see the first element of this list is changed into all caps. So if I need to all caps this all the letters, I need to run this command several times, like string list 1 equal string list 1 upper. So the second element will be capitalized. So likewise, I need to execute this three times to do like capitalizing this list. So you can imagine, like if you have multiple elements in this list, it will take forever for you to do like typecasting like this. Instead of that, you can use this simple command. If you need to capitalize all the things inside your list, you can use this simple command. So it's going to use like C upper from 4. That means it's going to loop all the elements inside this list, and it's going to upper. That means it's going to capitalize each and every item in this list. So if I run this one and print that list again, the same list again, you can see each and every item in that list is being capitalized. So also here, if I print like A, so A, I didn't create that day. So first I will create a day. Otherwise, you need to find this one in the upper part of this code. So here you can see, here I am creating the, otherwise you need to run this one, or you can create a simple list A with the integer numbers. So I will copy this one and paste it in here and try to execute. So now I have the list in here. You can see inside the variable panel, you can see in A it's like 0, 1, 2, 3, 4. And then I am asking, if I print this one, I will print this again. So you can see the values in the A is like integer list with the value 0, 1, 2, 3, 4. So if I then I am trying to execute some for loop for the entire all the items in this list. That means if x that mean x mean the value inside this list. Just imagine one value in this list you can assign as x. So if the x is less than 3, that means if the value if just imagine x equal 1, so it will compare whether that value is less than 3, or if the value is less than 3, then x plus 6. That means add 6 to the actual value. Else x, that means if the value is greater than number 3 or greater than the 3, that means you just imagine this case. So x equal 3 at this time. So it's going to do like the comprehension part here. So when it comparing the numbers, it falls. So it will, the else command mean do nothing and show x. Now you need to do this repeating part for x mean the value in the list A. So here my list name is A. So it's going to check each and every individual number, loop through each and individual element in the list and do this for loop. So if I run this one, so here without looking the number, you should be able to tell it, like if the first number is 0, so it will check. So the 0 is less than 3. Okay, then 0 plus 6 is equal 6. So the second one is 1. So 1 is less than 3. So 1 plus 6 is 7. Then the third number 2 is going to here. So then 2 is also less than 3. So 2 plus 6 is equal 8. Then this number comes like 3. 3 is less than 3. No, it's not there. Not less than 3, because it's not equal. Here we don't have the equal sign. If it is equal, it's true. So here it's not equal 3. So it's not going to add 6 for this element. So here I print like x. Then it will print number 3. Also for the 4, 4 is not less than 3. So it's going to show you the number 4. So here also you can try. If you need to change this one, just imagine if you need to compare with like 2. So what will be the list? Here it will be changed. So first 2 digits will be like 6, 7. Here it will be like 2, 3. So if I execute this one, it will be like 2, 3, 4. So that means you can do the for looping like this for the entire list without writing a loop. Then we came into the most important type of data in the Python. It's called the dictionaries. So previously we access the list items using this one. So here you can see these are the index numbers and these are the actual values. So here you can see these are all the 0, 1, 2, 3, 4, 5 are the index numbers. These are the index numbers and these are the actual values. Actual values of your array 1, 2, 3, 4, 5, 6 are the actual values. Instead of using this like index values, you can create something like a equal 16. So let me execute this one so you will understand. So you will understand. Let me execute this one. So here I am going to create the data type dictionary. So it will be created like A. If you whenever you going to access A, it will give you the value 60. Whenever you going to access B, it will give you a tuple data type 4 and 5. Then there's now another one like foo. It will show you this entire string. So if I execute this one, here you can see from this side is created. This list is created, is in dictionary data type. So here, if you expand this one, you have 3 variables inside this one, and the length is 3. So here you can see how many uh, items in your list, the dictionary type data list. So here you can see the difference. So in these normal tuples and the list, you can see the indexing 0, 1, 2, 3, 4, 5, 6. But in here, if you specifically focus on this one, here instead of 1, 2, 3, 4, 5, 6, you have A, B, 4, and whatever the thing that you assign. So you can access using these names instead of ones and zeros. So if you need to access the value of A, if you need to access the simple value of A, what should be the command? So it will be like this. So if you need to access A, then you need to type your dictionary type data. That means the variable name that you have given into your specific data set. So here I give my data set as my dic. So it's going to access from this my dictionary data variable access. That means the for indexing we use box brackets. Instead of typing like 0, we type simple A. Within brackets, we are typing within single brackets, we are within single commas, we are typing A. So if we execute like this, it will go show you the actual value of A. The value of A is 16. So it's showing you the value of A is 16. So if you need to check whether A or something is assigned inside your dictionary, the dictionary type data you can type within a single quote A in my dictionary. So this one will check whether there's an index named A in your list. If it is true, it will give you an answer like true. So here if I type like C, now I am searching whether C is in my list, like index, there's an index named C in my dictionary type data I have created in here. So if I execute this one, it should definitely give me the answer false because I don't have anything named C in my list. Here you can see I don't have anything inside my dictionary type data named C. So I cannot find anything in here. So the next one is if you need to view all the items in your entire list, you can type like your variable name, then dot items. So this is a built-in function. If I open the contextual help, let me open the contextual help in here. So on this side, so if I open this one and over here is going to show you all the items in the list that you have created. So whenever you see something like this, like a built-in function, you can view the doctrine. So it will give you what does that specific function is doing. So here also to view the keys, that mean all the index numbers, values in there, you can type like my dictionary.keys. So this one will be much more useful when you are handling with netcdf data. So netcdf or some kind of data like hdf, when you need to view all the variables inside your data, you can load the data into panda data frame or xarray data frame or numpy. Then you need to check what are the keys, that mean what are the variables inside your data. So you can use this specific thing. If you have dealt with the code like this previously, you should know you when you type like dot keys, it's going to show you all the variable names. So the actually is the index that you can use. So here, all the keys. So if I execute this one, it will show me all the values in my dictionary with the index and all the values. So if you only focusing on the index numbers, you can type like your variable name, then dot keys. These functions are only working for dictionary type data. So you cannot use like dot items and dot keys inside any other data type like float, integers, complex numbers, booleans, strings, list, or tuples. You cannot use these things. Only in dictionary type data you can use items and keys. So if you only need to focus on values, you can type your variable name dot values. So also you can see what are the other functions that you can use with this dictionary type data. So you just need to delete all the parts and your variable name, then put simple dot and you can press on the tab. So when you press on the tab, it's going to show you all the keywords, all the functions that you can do for this dictionary type data. So here you can see when you're accessing the values, you can use values command. When you need to update a key or something, you can use this update command. And here you have that keys that previously we discussed. When you need to clear, you can use the clear command to clear all the the items in your dictionary type data. And also you can copy your dictionary type data. Just imagine you need to create another copy of your dictionary type data. You can do it by using copy. So here we discuss about the values. So to access the values, you can type your variable name, then dot values. When you hit shift enter, it's going to execute and show you only the values. So here you can see dictionary values are 16, 4, 3, 4, 5 now. And here you can see the keys A, B, foo. And here you can see all the things. If you type items, it will it's going to show you all the keys and values. So let me minimize this one. Here you can see we discussing about the dictionary. So here these are the keys and these are the values. So the next thing is this one. So if you type my dictionary is going to give you error because there's no value inside this one. To get this one, like you can type, because previously I discussed here I cannot use like C, so it will give like, if I check here, it's showing me like false because there's no key named C. So here also the same. If you type like, if you are trying to access it using the key using C, it will give you an error because there's no, it's showing you a key error. So whenever you see something error like this in the red color, you should focus on the last line. So it will give you a hint. Where is your error? So here is showing me like key error. There's no key value named C. So, but if I type like B, I know there's a value. That means 4 and 5. So here, if I expand this one, the dictionary type data, I have B. That means in tuple type data, 4 and 5. But if I type anything, unless like A, B, or foo, it will give me error. And the next one is like, if you need to get the values of this one, you can type like my dictionary get C. It will give you the value. So it's not showing here because there's no value named C. But if you type A, it will show you the actual value. So here, like if you type C in here, it's not showing you anything. But you need to, because it's like false. By default, there's no value. That's why you cannot see a output. So in this second command, what you do is, if there's a value named for this key, specific key, if there's a value, just print that value. Otherwise, just print 1. Here you can put whatever the number you like, or 11 or 404, something like that. If you execute, it will give you 404 because there's no value for key C. That's why it's showing you 404, because in your dictionary type data, there's no key for this C, key named C. But if you type A, instead of 404, it will give you the value of A. Then the most important part is conversion of the data. Like when you trying to convert the data with the different type of data. So here, for the example, I will create two list. You also can create this two list. I will create two lists named A and B from this. The variable window I can see I have two a list named A and B because we use these two box bracket. Instead of using box bracket, if I use these brackets, what will be the data type? So A is in which data type? A is in tuple and B is in list. But here I use box bracket. That's why both lists are in the data type list. So here I can, to check the data type of the variable name A, I can type the type within bracket. I can use A or my variable name. So it will give me the data type of my variable. So if I need to convert this A into a tuple type data, what can I do is like, you just need to type tuple within bracket, what's the data? Whatever the data or the variable that you need to convert into a tuple type, you can give like tuple A. Instead of doing it like this, I will do like tuple within bracket A. So now you know the data is converted into the tuple type. Here is not going to show you an output, but from here, okay, tuple A. Then I will type print or type, not print, type within bracket. Here I need to assign a new list. Otherwise, it's not going to show me. Just let me create like variable C, tuple type data within bracket. And here, complete equal, because I can show this one C equal tuple A. So if I like print type within bracket C, I can see the C data C is in tuple type. So here also you can see the list. The A, B, C is converted into the tuple and assigned into the tuple variable C. So the next one is A. If I print A is still a list type data, but C is converted into the tuple type. The B is also still the list. And next, when you try to combine those things together, we can use like when you try to convert this data into a dictionary type data. Just imagine you have two different data sets. Here one is like A, B, C, and the other one is 1, 2, 3. Just imagine these are your station names. Here you can type like NKG, then CMB or something, and then you can type like SGN or something. So here it will be like your station names, and then here you can have like different temperature values of each and every individual stations. So just imagine you need to convert these combine these two into a dictionary type data. So to do that thing, you can use this one, D equal. That means you are creating a new variable named D equal. This new variable will be like dictionary, and then zip using A and B. So the first letter, that means the first list A will be your dictionary type data. We have like keys and values. So the list A will be all the keys, and the B will be all the values for those keys. So if I execute this command, now it's going to create a variable named D, and here you can see the data type is dictionary. Here you can see the data type is in dictionary. So if I expand this further, you can see the first list. That means the values in the A has been converted into, from here you can see values in the A as in here is converted into the variable, and that means the keys, and the B is converted into the values. So now I can access. How I can access the variable like the temperature value? Just imagine these are two temperature values, values and the station values. I need to access the temperature value of the NKG station, the short format. I need to access the temperature value of NKG station. So how can I access this value? So here I can type like D. So it will give me the list, entire list. So I need to access only the value of CMB station. Just imagine CMB station. So how can I access the value of CMB station in this one? So we have a dictionary type data, that means the list, and I need to access only the value, not the key, only the value of the CMB station. I know the short code of that station is CMB. Now I need to access the value of that specific station, not the entire data. I only need to access the value of the CMB station. Previously we discussed in the dictionary, whenever you need to access the value, you can either use this command or either use this command. So how I can access the value of CMB station? Just imagine the temperature value. Here we have the temperature values. How I can access those temperature values? Can someone respond? Like you can like unmute and answer, or you can type the answer in the chat box, or even you can put a message in the your WeChat group also. So I need to access this value. The station value name, station name is D, and my dictionary type data is in like my variable is D. Here I will type like stations, just type, I will type like stations instead of D. So it will be stations. I will type E dash. So temperature of the station. So I need to access from here. This is the dictionary type data T stations. From there, I need to access the value of CMB station. So here you can have multiple stations. For this specific purpose, I only created like three keys and value pairs. So from here, I need to, if I need to access the value of CMB station, how I can access this one? I can type like T underscore stations. That's my variable name of that list. And within box bracket, I can type with single commas, I can type CMB. So it should give me the value of that specific station. So that's why I say like when it comes to these all the data types, the dictionary type data is the most important one for our specific purposes. But you need to know about the rest of the data types also. In some scenarios, you might need to create those things, or you need to know about the basics of those things when you try to do like calculations or manipulations. So also like if you need to access any other stations, here you can type that key value, that means NKG or CMB or Shanghai. So here if I type stations dot key, so it will print me all the key values that I can use. So NKG, CMB and Shanghai. So here I will add another line T underscore stations. Then in the inside the box bracket I can type my station name. So here I can type any name from NKG, CMB or Shanghai. It will give me the specific value for this station. So if I need to view the value of the NKG station, I can type NKG and it will show me the value. So the next thing is that we are going to discuss about is like the logical operators. So I think you know about these things. Like this one is for the greater than sign to compare. If you are comparing two values, whether the value on the right side is greater than the value on no, value on the left side is greater than the value on the right side. The next one is greater than or equal, and the third one is less than. So here you can find those icons in your keyboards. So to compare the values, this one is to compare the values. So here, what does this mean? We discussed this one previously, because here is going to create a simple variable, one variable named x, and hold a value, the data type float, because here we specify like dot for after the number 5. So it's going to create a variable named x. If I go into my variable list over here, you can see I have created a variable x equal 5. So here also I can see that x equal 5 and the type of the x is in float. Also, I will create another value named y equal 5. This time y is in int type. So if I print y and compare x and y, here only difference is value is 5, but the data type is two different formats. X is in float type and y is in int type, but the actual value of those two data type is the same. It's the same. So if we type like x equal y, mean it's going to compare whether x equals to y or not. That means the value inside x and y variables are equal or not. So if the values are equal, it will print you as true. Otherwise, it will show you as false. So here, if I execute this one, is showing me true. But if I change here, this value into something named, just rename this one into 6. So now the actual value of x is changed into 6.0, but y is in y is equal to 5. If I execute this one, it will give you false because the values inside these two the variables x and y is not the same. So the next one is like simple examples. Also, you can type like this, whether x is y or not. So it is also going to check whether x is y or not. This means if, let me change this one. If the data, now x is also, the value of x is also 5 and the value of y is also 5, but we have two different data types. If I run this again, the answer will be true. But if I type like x is y, it's going to check both data type and the actual value. So here you can see x is a float and y is a int. The point difference address is in the memory. So it's checking the data type also. But in here, if you type something like equal, it's going to only going to compare the value, not the data type. If the value is same, it will print you like true. But if you type x is y, is also a comparison command in here. If you type is, it's going to check whether x is actually y or not. So it's not the same data type. That's why it's showing you as y. But if I type here instead of 5, if I execute like this, now both x and y are in same integer type data. So if I execute this one, it will give you true because both x and y is in same data type and the value is also the same. The next one is like the common comparison that we are doing, like because these things will be needed when we are doing some analysis, like when we need to extract specific data. Just imagine we are focusing on a specific range of temperature values or something. We need to do a for loop. We will discuss about this one in the next section. So here we can see we are discussing on the logical operators. After that, we will go for the control flow structures. In here we have if, for, and other loops structures that we are going to use in Python. So here are the logical things that you need to know before going into the for loop. So here I will create a two simple variables, a equal 5 and b equal 6. So you know both data types should be in because I don't have point or something at the in. So that means a and b are in both in the integer type data, and the value of a is 5, value of b is 6. So if I do the comparison, a equals b, that means it's going to check whether the value of a and b is equals or not. So values is not equals, that's why it's showing you as false. Then here, this one, the exclamation mark, then after exclamation equal mean is the not command. So here is like a not equal b. Actually here a is not equal to b. That's why you can see something like true. It's because a is not equal to b. If so, you see something like not equals, this is the command. Exclamation mark, after that without the space, equal. So it's the not equal mark. Then also you can do a comparison like this. So what does this mean? Can somebody elaborate on this one? This is specific command. Can someone elaborate on this specific command? On the left side and the right side, we have like two different comparisons. And the middle also we have another comparison. That means it's going to give us the product of those both comparison. So on the right hand side, you can see on this side, on the left hand side, you can see is check only the A, whether the value of A is greater than no, whether the value of A is greater than 4. So here we have the value of A is 5. So is greater than 4. That means this one is true. And on the right hand side is comparing the B. So B is less than 7 or not. Is comparing B is less than 7 or not. So here if we see the value of B, B is less than 7 or greater than 7. So B, the actual value of B is 6. That means this one is also true because B is less than 7. The actual value of B is 6. So what's the multiplication of T into T? That means here when it comes to the ones and zeros, 3 mean 1, false, true mean 1, false means 0. So we both have like true. The multiplication of 1 by 1 is 1. That means it's also true. That's why we see true as our final answer. But in here, if we change like this one value into the 6, now it's comparing the B value. B is not less than 6. So the output of this one is false. It's because the value of this side, value of A greater than 4 is true, and the value of B less than 6, this one is false. So this one is like 1 multiplied by 0. So the final value is 0 is equal to false. That's why we get something like false from this comparison. So the next one is A is checking whether the A is greater than 4. Okay, A is greater than 4, but B is not greater than 7 because the value of B is 6. So you should be able to write some statements like this. When you are comparing some values, you should be able to create some statements like this before you go for the looping structures or something. So you also need to know about these things before going for the analysis. And the next one is also checking A is greater than 4 and B is greater than 7. So it's the same command. That means here is not N, it's O. So if it comes to O, either when this command, this one and O, this one is true, the final output will be like true because here we are using O, not N. If you in here, N mean the multiplication and O means the plus. Just keep in your mind like that. N means the multiplication, O means the addition. So if one of these answers true and this one is false, so what's the addition of these two? True is 1, false is 0. The final value will be 1 because here we have addition. So the final value will be true. That's why we can see true in here. So here the main difference between this command and this one is, you can see the main difference is and, the first one is and, the second one is O. If you see and in somewhere, and mean the multiplication, O means the addition. So those are the two other things that you need to keep in your mind. So here also we have a simple statement. So if I created a list, the values x equal, the values of that items in that list will be like 5, 6, 2, 3, 3. So for this list now, I'm going to create a condition. That means conditional array to store whether the values are true or not. Those conditions are true or not. So now it's going to iterate over all the items in the list x. So here in x mean inside this list, go through each and every individual items and check whether the item is greater than true, greater than 2 or not, and iterate for all the items. So it will be get first item, that means the first item in the list is equal to 5, and check whether 5 is greater than 2 or not. So 5 is actually greater than true 2. That means the value of that thing is true. That comparison is true. Then the next value is 6. It's going to compare whether 6 is greater than 2 or not. So 6 is greater than true 2. That's why you can see true in the second one. When it comes to the third item in the list is 2. 2 is greater than 2 is not greater than 2. That means it's false. And 3 is true. So here, if I execute this one and view the values of the conditional list, you can see true, false, true. So I don't know you guys are with me or not, because I didn't see any reply from like anyone in the WeChat group or in the chat, whether you are following along with me or not.
We are following. Dinesh, we are following.
So here
We are
also
right
we have
here.
like two commands. Like if we view the doctrine of this old command, that means old is also a by default command. Command mean actually a function. So that's why we have a doctrine for this one also. If you open the contextual help and put your cursor in here, you can see all, that means iterable, it will return true if boolean x is true for all values in the x. So here you can see all the values are not true. We have false. That's why we get false in here. So any is also a variable like a function like that. In any function is like give you, like if there's anything named like false, it will give you as true. If you see any item inside your conditional list named false, it will give you output as true. Here also like simple variable name. If you need to create whether it's true or false, true type data, you can, we discussed about this one previously. A equal true mean you are creating a variable name A in Boolean type, and the value of that one is true. So if I print this one is true and not A mean the inverse of the Boolean value. So in reality, value of A is true, but I need to get the inverse of that one. So here you can use not. So it's going to inverse the actual value. So actually the now it will be like false. Then the control flow structures in here. Here you need to, the one thing you need to know is like you cannot use like simple characters like this. When you creating true and false like Boolean type data, you cannot use simple true or simple false. You can see it's not even highlighted in green. So if I type like true capital, you can see the difference. Here is okay, but if I type like A equals simple TRUE, you can see the difference. So you also need to know about this one also. Just keep in your mind when you are assigning data, specifically on the Boolean type, you need to type it like this, not like this. So if you type like something like this one is not going to work. You can try to execute it, will give you an error. See, true is not defined. So it's checking for a variable name. It's not understand what this true means. But here is understand. This true means the Boolean type data true. So the next one is like control flow structures. When you are going ahead with the coding, in Python, we don't have anything. So here you can see in Python, there's no annoying curly brackets. If you dealing with R or any other programming language, you know, we have to have like multiple parentheses for each and every function. So here you can see for the first function is list. Inside that function, I have another function named range. So for this function, I should have, for the range, I should have opening parentheses and the closing parentheses. Also for the list, I should have opening parentheses and the closing parentheses. But in Python, we don't need to use this brackets. But in here, you need to focus on this one. Indentation. Here, if you make like if you place one space wrong, here you can see 4x in range 10. So it's going to do a loop. And here I'm like checking to like if x is less than 5, print this one. If not, print this one. But here you can see these two commands are the two print commands are in the same line. If I draw a line across this one, you can see these two lines are in same line and these two are in same line. But if you type something like this, so just imagine you put one space like this and else is here and if is here. So now it doesn't understand. This one, this else command is under this if statement, not under this for statement. So if I run this one, it will give me an error. So here you can see, here is showing me like indentation error. So you will see a lot of errors like this if you like do your indentation incorrectly. So here you can see the indentation error. That because this if and this else is not in the same line. So if I make it like same in the same line by using the tab, now it will execute. But if I make something like this, it's not going to execute. So you need to pay your close attention when you are dealing with these kind of like looping structures, specifically when you are doing like looping or creating a function. You need to focus on your indentation. It should be like in a proper way. Otherwise, you will see some errors like this. Sometimes you will never receive an error and you couldn't even find where you did the wrong. So you have to proofread by yourself. Where did you put a simple space? Even a simple space is okay. See here, I in the eye level is okay, but if I closely inspect, if is one space to the right side, even that you will get this kind of error. So you need to pay your attention for the indentation when you are writing the codes, especially in the Python. So here, if I discuss about the function, it's like creating an array with the range. Range function is if I go into the doctrine of the range, let me paste in here. So if I go into the doctrine, let me type something like range within bracket. So here you can see range is stop range object. So return an object that proceeds a sequence of integer from starting to stop. So here if you you can put either two values. So if you put two values within brackets, so it will be going to create integers from 20 to 24 if we type like this. Otherwise, if I type like range 20, it's going to create from 0 to 20. If I execute this one, let me delete this one and execute this. So here you can see it's going to create values in the range from 0 to 90. So here you have like 20 values, integer values, and assigned into a list type data. So range is inbuilt function whenever you need to create a simple number sequence. So here is also going to create a simple number sequence that means from 0 to 9, and it's going to compare whether the x is less than if the value of x, the first one from in this list, what will be the values? 0, 1, 2, 3, 4, 5, 6, 9. So the first value will be 0. So 0 is less than 5. That means it will show you 0 to the power 2, because we know that 2, if you see 2 stars, that means it's not the multiplication, is power. So x to the power 2, that means 0 to the power 2 is 0. Then the next number in that list will be 1. 1 to the power 2 is 1. Then 2 to the power 2 is equal 4. If I execute this one, you can see for here it will be like display like 4 to the power 2. After that, the number will be like 5. It will be 4. So it will execute like 5, 6, 7, 8, 9. So if I execute this one, you can see 0, 1, 4, 9, 16, 5, 6, 7, 8, 9. Also here we can like simply do like for looping structure. For I in range of 10, print all the values in I. So it will show you all the values in your variable. So next we are going to discuss about this if and else statements. Here you can, when you need to compare whether this specific data is belong to this category and this category, like marking, just imagine a marking. You have like different scores for different students and you need to go for a marking. You will check whether the actual value is greater than this one, then A. If the value is greater than 65, it will be like B. The result will be B. Or the value is greater than 55, the result will be C. Likewise, you can do a comparison. So here we created a simple value x equal 10. Now it's going to compare. If x is less than 10, do this one. That means x will be x equal x plus 1. So here x is 10. We define like x is 10. So this one is not going to execute because s is not less than 10. And the next one is after comparing this if statement, first it will check whether this one is true or not. If it is true, it's going to execute this command. Then it's going to check. If this one is false, it's going to check the next statement. That means if else if. Now it's going to check this one with the x, whether x is greater than 10. So 10 is not greater than 10. So this one is also not going to execute. Then the last one. If the second statement also false, it will go for the third statement and check whether x is here else. Else mean if none of these x statements are true, just execute this statement. So that means it's going to print x equal x times 2. So if I print this one, what will be the value? Because here I am comparing the 10. 10 is not less than 10 or 10 is not greater than 10, but the default statement is like x equal x to the power x times 2, not to the power x times 2, because here we see only one star, that means a multiplication. 10 times 2 is 20. So the final answer will be 20. If I change this one into 11, what will be the answer? Can someone elaborate? What will be the answer? According to this simple statement, this simple comparison, what will be the answer? So it will check, first it will check whether x is less than 10 or not. So here we know x, the value of x is 11, is not less than. Then it will go for the second statement. In the second statement, is checking whether x is greater than 10 or not. So here we know x is greater than 10 because the value is 11. Then 11 minus 1 is 10. So it will execute this command, not this one. But I can execute this one. You can try to play with this command. So if I execute this one, so here you can see x is greater than 10. So x minus 1 is equal 10. So here if I type like 5, what will be the answer? So the first command will be first comparison, like the first thing in here will be executed. So here at the beginning we are checking if x is less than 10, do this one. X equal x plus 1. So the value of x is 5. 5 plus 1 is 6. So if I execute this one, the output will be 6. So likewise, you can do like multiple comparisons also. So here I am doing like multiple comparison. Here I am assigning a variable named x equal 10 in the integer type data, and in the first line I am checking whether x is greater than 5 and x is less than 8. That means the both of these statements we should be true. The x should be like greater than 5 and also x should be less than 8. That means x should be within the range of 5 and 8. So the simple meaning of this one is x should be either 6 or 7. If x is 6 or 7, this statement will be true and it will execute this command. And the next else if command is like, if this one is not true, check the next statement. In the next statement is checking whether x is greater than 5 and also x is less than 12. That means x should be in the range of 5 and 12. That means either x should be 6, 7, 8, 9, 10, 11. One of those 11, if the x is, the value of x is falling between those numbers, it will be true and execute this command. Else x equal x minus 1. So here we know the value of x is equal 10. So if we go for the first comparison, it is like checking, okay, x is greater than 5. So this one is true. And the next side, the right side, x is less than 8. No, x is not less than 8. So the final value of this one is false. So it's not going to execute this comparison. So it will go for the next one. In the next comparison is checking x is greater than 5. So the 10 is greater than 5, and then also it's checking 12 is greater than 10. So it's going to execute this one because the answer of this one is true. So when it's true, it's going to execute this one. So the value of x is 10. 10 to the 10 times 3 is 30. If I execute this one, the output should be 30. But if I type something like this, just imagine I will type a value name like 6. So it's going to execute the first statement. 6 plus 1 is 7. If I run this one, the answer will be 7. But if I type something like, okay, x equal 12, what will be the answer? So it's going to execute the last statement. So that means x equal 12 minus 1. The answer will be 11. So you should be able to create these kind of simple comparisons using if else. So this one is like only if else to do like comparisons. The next thing is like loop. Just imagine for here you are only checking for single value, but instead of single value you have an entire list to check like this. So you have values in like 12, 13, 14, 15, 16, like those numbers in the list. Now you need to check all the values in that list. So you need to loop through each and individual item inside your list. So you cannot loop through each and individual item in your list like this. For that thing, you need to use for loop. So here is like checking. So count is equal 0 and x is in the range of 1 and 10. So what does this mean? Count 0 mean is creating a variable named count, value is 0. In here is creating a variable name x. Actually, this should be a list because range 1 to 10 is going to create integer numbers. That mean 1, 2, 3, 4, 5, 6 up to 9. A list with the integer numbers. For that I in x mean all the items in the list x do like count equal plus equal I. That mean we discuss about this one. What does this mean? Count equal count plus I. So it's going to loop through each and every individual item in this list. It's going to loop. So the first item will be 1 in this list and it will be passed. And then count is the value of actual value of count is equal 0. Equal 0 plus I is the first number value of this list. It will be like 1. So it's going to do the addition, like summation from like 1 to 9. So if I execute this one, it will show. See, the first one will be 1. Then the value of count will be 1. Here, the next value will be passed into that list. The next value will be like 2. Then 2 plus 1 is 3. So it will be showing you the second one. Then the actual value of that count will be changed into 3. And the next value in the list will be like 3. Then 3 plus 3 is equal 6. So the value of count is changed into the 6. And then is checking the value on the your list. It will be like number 4. 4 plus 6 is equal 10. Likewise, you can get the sum also. So you can try to change this one. Just imagine if you need to do this one into your entire list. It's also possible. Next one is like try catch. This one is like if you can try to do some execution. If the answer is true, it will give you a value. If it gets an exemption or an error, it will give you the value you put for the exception. So here I created a variable. That means here you can see what will be this highlighted command will execute. It's going to create a string type data. That list will be simple A 1, 54.1, 43.A. So here I'm going to loop through each and every individual item in this text. So it will try temp is equal float T. Then it will print. Now it's going to change. So the first item will be like A and try to convert it into a float value. If it is an string number, we cannot convert the string into a float type data. So it will go for the exception. So here it will show you an exception. So for the exception, I'm going to do it like this. The string, then the value. That means A is not convertible to a float. So what will be the output? The first number, now it's going to iterate through the each and every individual item in this list. The first one will be A. So A is, if I would try to convert A into float, it's an exception because we cannot convert string type data into the integer or float numeric value. So it is going to show me like A is not convertible to a float value. But the second item in this list is 1. So float 1, it will convert into 1.0. Also this value 54.1 is also going to convert into a temperature value without an issue. But the last value, when it comes to 43.A, is trying to convert it into a float type data. 43.A cannot be changed, convert into a float type data. So it's going to give you execute this exception. Also, if I type something like, just imagine if I type something like NKG, let me type NKG. So the last one will also be like not convertible into a float. Here we can only change these numerical values. If you have a numerical value, it will be converted into float. If you have some like string type data, it's not going to convert into a float type data. So here you can use this try and catch exception to filter your data. For the in your purpose, you will use like, just imagine you have in a single column you have multiple values and you need to extract only the numeric values inside that list, not the string type data, only the numerical values inside that list. You can type simple command like that and create a specific array to extract only the numerical values by using try and exception command. So next we have like recycle code in Python. Just imagine the recycle code means if you are using same thing, you are in this example I discussed about previously. Just imagine you have multiple station data. Now you need to convert those data into like your actual values are in Celsius. Now you need to convert it into any other data format like Kelvin or something. So instead of doing for each and individual station like separately, you can create a function. That function, main purpose of that function is to convert whatever the value in your list into a Kelvin value. So you can create a function and use that function instead of repeating that same thing again and again inside your code. So that's why I type like something named recycling code. So here we can do something like this. Just imagine you in your research you going to use value of pi in somewhere else multiple times. So you can have a variable name pi equals 3.1459 at the top, and you can use whenever you are going to use that numeric value, instead of typing 3.14159 each and every individual times, you can use pi instead of typing that actual value. Then also you can create these kind of functions. So here I am like from NumPy I am importing our cos, because in NumPy we have like cos inverse. That means the cos inverse function. So import cos inverse function, and we are going to use that function also in there. Also we are going to create def fx. That means we are going to create a function named f. Whenever we know like function name f, it will return the value you gave plus 5. So here, this is this one. So here I'm going to write this one into a variable named, I'm going to write this one into a script file. So here, if I go into here, uh, I don't have a file name, some module file dot py. Here I will type like my module. So I will type my module dot py. I'm going to create a script, my module py, and in that script I'm going to having value of pi, and also I'm going to import numpy as our cost, and also I'm going to define two different functions. So the first function will be like fx. In this function, it will return uh, value plus 5 to its arguments. So here it's the doctorate. So that's why you can see whenever you like in the contextual help, if I go here and like click over here, you see something like this, because in the range function in Python, we have this range function by default created. But if we are creating some functions like this, we need to give our own doctrine. So we need to type our doctrine like this. Otherwise, we cannot see something like this in our contextual help. So that's why I am doing like something like this in red color. So in the first function, my doctrine will be like this function is which adds 5 to its arguments and returns the value. So the also I have another function. Here I need like you need to pass like two values named x and y. It will return the addition of those two arguments. So if I execute this one, it's going to create a py script file. So if I refresh here, you can see uh, on this side I have a Python script named my module. So I can import this one whenever I need it in my code. But I know in there I only have these two functions and the value of pi, and I imported the variable from like cos inverse function from the NumPy library. So if I use this Python script, in that script I have the value of pi, and then numpy, the cos inverse function, and then the simple function which adds like 5 to the value I passed there, and there's another function like if I pass two arguments, it will give me addition. So how I can load this script into uh, Jupyter Lab? So here I need to type like import, then your py script name. So in here, my py script name is my module. So I can type like import my module. Now it's going to import this script into the Jupyter notebook. So if I execute this one, it's going to import. So here, if I click on import my module, here you will see the doctorate. So here you can see, now I'm importing this function inside into my Jupyter notebook. So if I type like dir is the command you can type to view all the functions inside anything that you have imported. So here I imported my module. Now I need to check what are the inbuilt functions or the variables inside that script I imported. So I can copy this one or I can type dir my underscore module. So it will give you me all the functionalities inside that script. So here I mentioned I have a value name 5. So here you can see 5 at the beginning. Then we have some built-in things like build bulletin, cache, doc, file, loader, name, package, specs, those things. Then I imported like arccos. So here you can see I have a function name arc cos, that means cos inverse. And also I have a function name f. And also I have a function name g. Now I can call for these functions anytime. So here I am typing like help some module. That means it will give me the doctrine of that specific function. If I type like help within bracket, the Python script, py script I written in here, it will give me the help regarding that thing. So here you can see name my module. I have two functions. This function which adds 5 arguments and this function which adds 2 arguments, and I have two type of data. One is pi value and the other one is arccos function. So it will give you something like this. So the additional details regarding that function. So if you need to use arccos function, how you can use it like this. So now I need to access that pi, the value of pi from the library I imported. So here I imported as my module. Now I know I have something named pi fg in there. So you will understand this one, what I am saying, because I'm importing my module. So if you deal with like numpy or xarray, you are importing like import numpy as np. That means whatever the inbuilt function in NumPy, you are going to access using np command. If you type like dir np, after typing like import NumPy as np. So here, let me type that thing also. Import NumPy as np. So here NumPy should be in capital like this. Very simple. So as np. So now I import two modules. One is the script that I created, and the other one is NumPy. So if I type like dir np, it will give me all the functionalities inside NumPy. So these are the commands that I can use using like built-in functions inside the NumPy. So here you will see each and every individual function that you can use inside the NumPy. Likewise, you can write your own functions. So here I created my own functions inside this Python py script, and I load that one also, and I load the NumPy library. Inside NumPy library, I have a lot of functions. Here you can see I have a lot of functions. All of these functions I can use. Whenever I need to use NumPy library, I can use these all the functionalities comes with the NumPy library. So likewise, you can check. Just imagine you also imported any other libraries, xarray or cartopy or something. You can type import numpy as np. Then you can type dir whatever the way you imported. Here I imported numpy as np. So instead of using numpy, I am going to use .np in my command. Whenever I type like np, it's going to represent the numpy library. So now if you need to check what are the functions that you can use using that NumPy library, you can type dir. So here we have a doctrine, shows attributes of an object. So it's going to show whatever the attributes or the functions inside that module you load. So this one is also you need to keep in your mind. Whenever you imported a library and you need to check what are the built-in functions inside that library, you can type dir within bracket your library name. So I have loaded that one. We are discussing about that thing. This one is like an additional thing for your knowledge. So next also we can type like help np. So it will give you all the necessary help functions. What are the functions in NPy library? So if I execute this one, it will give you like multiple lines and it will take some time. because we have a lot of functions over there. So here you can see name is NumPy and the description and the providers and generation and blah, blah, blah. You will see a lot of stuff regarding the NumPy library. All the help is going to load up all the help files in that NumPy library. So see, now it's going to crash. But you can see if your machine have high like capabilities, it will load. Otherwise, it's going to crash like this. So let me run this again. I will close my Jupyter Notebook session and I will rerun this again. Otherwise, this one is not going to work. But you can check. If you need to check, you can check. But it depends on the specs and everything with your PC. Okay, now I have loaded it again. So let me go into the bottom section. We are discussing about control flow structures and recycling code. So here we view all the functionalities in the NP and then we trying to check for that one. So in my module, I will import because I have to import previous libraries from the bottom part. Let me import these two modules and check what's inside my module. So here I know I have two functions, py and the help function also. It will show me all the documents inside there. And now I'm going to access pi. What's the value of pi? So here I can import this one as my module. If I type import my module as m or something, so I can use simple m instead. Instead of typing a whole name, I can type like m. If I type like m, it will give you the same output. Instead of typing my module, I can type simple m. So it will be simplify for me further. Now, if I need to access py value, instead of typing my module, I can type like m.pi. So it will give me all the values. So now you know, if you need to know all the functionalities of inside that library, what's the command? You can simply put like the module name you imported, dot, then you can press on tab. So when you press on tab, you will see all the functionalities comes with that function. So here I have like value of pi and the rcos function and the f function and then the g function. So here you will see instant, and these two are functions. So if I need to check about this function, I can type like we discuss about this one. I can type a comma and hit enter. So it will give me the doctrine in this one. So it shows me the doctrine which I typed earlier when I creating this function. Here I created f. This is a function which at 5 to its argument. So this is the doctrine. So whenever someone is going to use my function, the function that I have created, he can check about this doctrine. Now he will understand, okay, if I use this f, it's going to return a value, we like return the value with the addition of 5 to the arguments I am passing into that specific function. So here also he can check the doctrine. Otherwise, if I need to access the pi value, I can type pi. So it will give me the value of pi. Let me type m because I imported it as m this time, not some module. That's why I give error like this. So here I can type m dot, then tab pi, hit enter. It will give me the pi value where is from my function. Here also I can type m help some module for m dot f. So it will give me the help function or the doctrine. So it's going to give you this function which adds 5 to you its argument. So how I can invoke this f function? So I will add a line. So just imagine I need to do addition. into some value. So I can type like m dot, my function name is f, within bracket, I will type 5. So if I type 5, what will be the output of this command? So now you know I am calling for the function that I have created inside my specific module I created in here. So I have my module. Now I imported this as m. From there, look for this function name f, and I am passing one value. So what will be the output? Here, the function which adds 5 to its argument. So here my argument is 5. 5 plus 5 is 10. So if I execute this one, I should get an output as 10. So here you can see, if I type something like 10, it should give me an output named like 50. So likewise, if you have some multiple functions you are going to frequently use, you can create your own script and use that inside your code also. You have that functionalities in here also. And also here I have created another function named G. So how can I check this doctrine? Can someone tell me how I can view the doctrine of this function? Because inside my module I created two functions. If you remember, here I created two functions. One is f, other one, the function name is g. So how can I view this doctrine? Using this command. I imported some module as m. By the module name I given into my Python script is my module. From there, I'm going to invoke the second function, the function named g. So if I need to view the doctrine, what will be the command? So I can type like m dot g. If you have the contextual helper load in the other side, you will see the doctrine. Otherwise, you can type m.g, then comma. So it will give you the doctrine. So whenever you invoke this one, you need to pass two arguments, name x and y. So if you pass two arguments, this function will return you the sum of those two variables. So here I am going to invoke that thing, m.g 5, 10. So what will be the output? It will give me the output of the addition of these two numbers. If I type like 10 plus 10, it will give me 20. Likewise, you can create your own functions and save it in a script, and you can load that script whenever you need. I think you understand that one. So also, if I need to import only one module, instead of loading the whole module, I can do it like this. So you will see something like this also, because in here, also I code like from NumPy import Arcos. So instead of loading all the libraries, all the functionalities in NumPy, I'm only importing the cos inverse function. So here I load all the libraries, all the functions inside NumPy as NP. But if I type import NumPy, then from NumPy, instead of import, I type like from NumPy. That means access the NumPy library from there, import only this function. So it will import only that function. It's not going to load all the functions into your memory. So it will, you might see when you are dealing with the Python, you might see like memory exemptions a lot. So that means you are loading each and every unnecessary libraries inside into your memory. That means into your RAM. So your RAM will be unable to handle a lot of libraries. But you are not using all of those libraries. You are only using few libraries from there. So if you understand what's going actually behind your code, you can only import those necessary libraries instead of importing the entire library into your memory. If you load entire library into your memory, your PC will be crashed, or it will be slow down, or it will take some time for the execution. So likewise, if I need to import only the f function in my module here I created, I can type like from some module import f. So here is my module. From my module import f. If I type like f with using comma, it will give me like the doctrine of that function. I don't know you guys are with me or did you understand this? Because I didn't receive any like comment in the chat box or even in the WeChat group whether you are receiving any issues or not. Because you need to understand about these things. These are small things, but you need to understand about these minor things. So here also I can directly invoke that one because here I imported it as F. Instead of loading like m.g or m.f, I can directly call F because here I only imported that specific function. Not all the function is inside that library, only the F. So here also I can import this one as import my library as this one because I imported this one as like this in the top command. So those are the basic things that you need to know about, like specifically when it comes to the Python. So I think we don't have the time. If we have time, we can go for like the next one because NumPy. We need to talk about NumPy because NumPy is the thing that we can use like for the handling the arrays. So let me start this NumPy one also. I have sent this one into you also. Like you can go into your notebooks and you will see something, some folder named NumPy. If you go there, you will see one script, one notebook, Jupyter notebook over there named like NumPy Basics. You can load this one. So now we are going to discuss about this NumPy library. Because here, when you are dealing with like array type of data, we need to use NumPy. The next one is we are going to discuss is like pandas. Pandas is like data frame. When you are dealing with tabular data, you have to use pandas. The next one is X-array. When you are dealing with like time series data, that means the netcdf or like three-dimensional or multi-dimensional data, you need to know about X-array. After that, we will discuss about the X-array. Once you know about these three things, NumPy, pandas, then X-array, you can import any kind of data into your Python environment. You can import any kind of data like CSV, text files, netcdf, HDF, or any sort of file you can import. After that, we can go for like the discussion like SkyPy library. That means SkyPy will use lot of like in if you are doing like scientific calculation or scientific something analyzed regarding that thing, you need to use SCIPY. That means SciPy library. You have to use that library. So now we are going to start discussing about NumPy basics. So you need to know about these things, a little bit about these things. So here we will discuss about what are arrays and how can arrays are manipulated effectively in Python. Also, we will discuss like how to create an array type data and how to perform basic calculation from data using Python math function and how you can slice and index the arrays. So also I will give you another two scripts I have created here. We need to discuss about like broadcasting and vectorizing. Like broadcasting mean if you have like the two different shape arrays and how you can do like broadcasting. If your array shape is not equal, how you can deal with those types, how you can do multiplication, how you can do addition. For that thing, we need to know about like NumPy broadcasting. And also we will go with like this one, the intermediate NumPy. Here we will discuss about some experimental data, like how you can do and what we can do if you know something regarding NumPy. Because here we can like get the sum of an entire row or entire column easily without looping through one by one. So in the next session, I think we can discuss about it in the next session because the time is almost like 8. For me, it's okay. I don't know about you guys. If you can continue, it's okay. Otherwise, we can stop for today and we can discuss about NumPy from Monday. If you guys are okay, we can go ahead. Or if you guys have any questions, we can discuss about those questions right now. Regarding the Python basics, if you guys face any problems or any issues, we can discuss about that thing right now. Did any of you face into a problem while like running those scripts in the Python? Yeah, okay, we can continue on the next session because we have some problems with like connection and those things. By the way, Mr. President, do we have a QR to scan for today's session? So do we need to scan
We,
or
we,
do we
we,
need
we, we
to take
didn't
the attendance?
collect
Do we need to take attendance?
line that is already recorded. For other guys, we excuse not.
So here you can see, first thing is we need to import NumPy. First thing we need to install. Actually, when it comes to like when you are dealing with your own data, you need to start from the beginning. Now in my Conda environment, I have NumPy installed. That's why I am importing NumPy as NP. Just imagine you have your own environment. So let me create an environment first. So I will create an environment. So what's the command to create an environment? If you're dealing with Conda, what's the command to create an environment? So I will create, this is the first thing. If you are creating your own, for your own experience, if you are creating something, you need to create the environment. I will create a test environment, Conda. Then create.
Yeah.
So now it's going to create me a different environment name test. Because right now I'm working in IMSA, that's why. In IMSA, I have installed all the necessary libraries. That's why I can import NumPy as NP without any issues. Just imagine if you have one different environment, you need to create that environment first. So if you are working on your research, I suggest you to create your own environment and you can install all the necessary libraries into that environment. So for the first thing, you need to create environment. I will create a test environment. Otherwise, you will see a error when you try to import NumPy as NP. There's no library name NumPy or something, and then it will show you like use pip install NumPy or something to install NumPy into your variable like that. Okay, I think we don't need to scan any QR today because we all are joining the meeting online. We don't need to get any attendance because the attendance is automatically registered, like recorded when you registered for today's meeting. The attendance is automatically registered, like there, so you don't need to worry about that one for the attendance. So here the environment is created. So now I can list all the environments. From there, if I execute this one, you will see all the environments in there. So I have a name, the environment name test. Now I will activate Conda, activate test. So now from that environment, if I try to like execute Jupyter lab, Jupyter lab is not there. So I know this one is not going to execute because Jupyter lab is not there. So for this one, first thing is I need to install the Jupyter lab. Even NumPy I need to install. So the first thing is like conda install. So here I put a slash request slash in this one. So I think you know about this one. When you're creating an environment, you need to create the environment and install all the necessary libraries before you are going to import like this. Here, before you're going to import any sort of library, first you need to create your environment and you need to install all the necessary libraries there. Then you can import any library you install into your environment. Otherwise, it's not going to work. For now, you all will work. For all of you, this code will work because I have installed all the necessary libraries that you need to work on these scripts. That's why it's going to work. Otherwise, it will not going to work if you going to create different environment with different libraries. So it will take some time. So I think we can wind up today's session because this one is going to take some time for the installation. So I think we can discuss about this one in the next session, like NumPy. We'll discuss about NumPy on the next session. I will send you the other two Jupyter notebooks into the group. You need to copy those two notebook files into your NumPy folder. And we will discuss about NumPy in the Monday session. We will discuss about NumPy. And if we have some time, we will go ahead with like Xarray because we need to know about those three libraries, NumPy, Xarray, and Panda. We need to know about those three things before we going in with any kind of analyze. Because those are the libraries we need to know when we going to import data from like any sort of file, CSV, text, grid, HDF, netcdf, or any sort of file. When we are going to import it into the Python, we need to know about those three libraries. The famous one is NumPy. The next one is Pandas. If you are working on the tabular, the Panda is the great option. If you are working with like multi-dimension data, Xarray is the best option out there you can go for. After that, we will discuss about like some packages we need to do like data analysis and data manipulation. After that, we will discuss about like the libraries we are going to use like Cartopy and Matplotlib. Those two are the libraries that we need when we are going for the plotting. But before we go for the plot, we need to understand how we can get the data and how we can do some analysis with our data, and then we can do the plotting. Even if we are not going to do any analysis, we need to know how we can read the data. If we know how to read the data, then we can go for the plotting. Before doing any analyzing, we can also do for the plotting. But for the first thing, we need to know how we can read different type of data. So we will discuss about that one in the next session. So here now the Jupyter notebook, Jupyter Lab is installed. So I will try to load Jupyter Lab inside my test environment. So now I am loading Jupyter Lab inside my test environment, not in IMSA environment. So here, if I load this Jupyter Lab, let me open this one. Okay, it's opening. So here, if I try to import that NumPy module, so the first one is like import NumPy as NP. If I try to execute, this one is not going to execute. It will give me an error because I know in my test environment, there's no module named NumPy. So here you can see no module named NumPy. Previously, I didn't get any error because I was using not the test environment. I was using IMSA environment. In IMSA environment, I have installed all the necessary required libraries for these scripts. But now I am using the test environment. In the test environment, I don't have a NumPy installed. So the next one is I need to install NumPy into this test environment. How I can install NumPy? I can type like conda install NumPy. Then I can hit enter. So now it's going to download that library into my test environment. After that, I can import NumPy as NP, or from NumPy import any one or two libraries I can import. So this is the general procedure. If you are working on a new script or working on your own project, just created that environment, then you need to import one by one libraries one by one into your environment before you are going ahead with like you analyze or something. So you whenever you see something like this, when you are trying to import a library, module not found error, that means that library is not installed in your environment or in your Python installation. So you need to install that library into your environment first. After that, you can import. But if I type like import my module from here, it's going to import because I have that script in here. So it will import. But these are like default libraries. It's taking whether these libraries are in the default location of your environment. So if I hit enter, now it's going to download all the necessary libraries for the NumPy. After it's downloaded, I can open up my Jupyter Lab and try to execute this one. So that's why I discuss about this a lot during the previous class, how to create an environment, how to install the variables. So how you can activate. First thing is like you need to create the environment, then you need to activate that environment, because all the packages, like all the conda install commands are going to install those necessary packages where you are right now. If you activate like test environment, is going to install those packages in the test environment. Because you can see in the front, now I am activated in the test environment. Whatever the libraries I'm going to install, those all the libraries are going to install into this test environment, not anywhere else. Okay, now that thing is also, NumPy is also installed. If I run Jupyter Lab again right now and try to import NumPy, it's going to import because in my test environment, now I have NumPy in my test environment. Now it should work. So here now I have NumPy in my test environment. So now if I run that same command, import NumPy as NP in here, now it's going to import NumPy as NP because in my test environment now I have NumPy over there. So you will see one is here. So that means NumPy is imported. So here if I type something like dir, we discuss about dir command. So dir within bracket, then you can type np. So it will give you all the functionalities inside NumPy. See, that means NumPy library is loaded into your Jupyter Notebook environment. So we will discuss about NumPy on the next session and see you guys on Monday. If you have any issues, you can like type it on WeChat or you can put it in the group. Or if you have any issues like during this, like the previous introduction to Python script, if you have any issues regarding any section, we can discuss. Or not, we can finish the class for today. Like it's almost 8:30.